Okay, question 21. Determine the slope of each of the following, show all work. So part A, the line passing through the points -4, 1 and 2, -2. So M is equal to y2 minus y1, or x2 minus x1. So our y2, -2 minus 1, all over x2, 2, and then minus -4, which will give us -3 over 6, which simplifies down to -1/2. Part B, the line passing through the points 3/4, 2 and -3, 17. So M again is equal to y2 minus y1 over x2 minus x1. y2 is 17 minus 2 over -3 minus 3/4, which is equal to 15 over the bottom. We're going to have to convert that -3 to be the same fraction, so it would be -12 over 4 minus 3 over 4, which is equal to 15 over -15 divided by 4. We can then multiply by a big word here, the reciprocal. So that'd be 15 times 4 over -15. So the 15s will cancel. We'll be left with 4 over -1, or equal to -4. Part C, a vertical line. So let's remember the vertical line looks something like this. So we have a rise, but our no run. And we consider that undefined. Part D, a horizontal line. So this one we have no rise over our run, or 0 over run, which is 0. With part E, y equals 2/3 x minus 5. By inspection, we can see that this is in its slope-intercept form, where M is the slope of the line. So here, M equals 2/3. Part F. We have 3x plus 4y equals 4. We really want it in slope-intercept form. So let's do the math to get it into slope-intercept form. going to subtract 3x from both sides. And then we are going to divide by 4. Now that we're in slope-intercept form, that term in front of the x is our slope. Question 22. Write an equation of the line in slope-intercept form that passes through the point -1, -4, and has a slope of 3. So slope-intercept form is y equals mx plus b. From the problem we were given that m equals 3. So we can plug that in. And then we need to solve for b using our point, where we plug in -1 for x and -4 for our y. Now that we have that in there, we can solve for our b. So you get -4 is equal to -3 plus b. Add 3 to both sides. -1 is equal to b. Now that we have both our m and b, we can put it into the slope-intercept form. Question 23. Given the function defined by f of x is equal to x cubed plus 2, determine the average rate of change on the interval -3 to 0. So we need to find f of -3, which will equal -3 cubed plus 2. So -27 plus 2, -25. And then also f of 0, which is 0 cubed plus 2, f of 0 is equal to a positive 2. Now we have an ordered pair. For our slope equation, which is y equals y2 minus y1 over x2 minus x1. So here we'll have 2 minus a -25 over 0 minus -3, which will be 2 plus 25 over 3. So the average rate of change over the interval of -3, 0 is 9. Question 24, write an equation of the line in slope-intercept form that passes through the points 2, -5, and 7, -3. Show all work. So y equals mx plus b is our slope-intercept. So the first thing that we need to go for is the slope, which is m equals y2 minus y1, x2 minus x1. So this will come from our different values here. -3 minus a -5 all over 7 minus 2, which will equal -3 plus 5 over 5, which will equal 2/5. So that's what our m equals. Now we can choose either point that we want to do to find our, I'll just select the 2, -5. So -5 is equal to 2 times 2/5 plus our b. -5 is equal to 4/5 plus b. We can subtract the 4/5 from both sides. So we get -5 minus 4/5 is equal to b. We could plug this into our calculator, but we can also find a fraction at this point. Or -29/5 is equal to b, leaving our equation as y is equal to 2/5 times x minus 29/5. Question 25. Lines R and P shown in the graph below are parallel. Find the equation of the line P in slope-intercept form. So we want something in y equals mx plus b form. And we want to use P, but we only have one point on P. This is where we need to remember that parallel lines have the same slope. And if we look at R, they gave us 2 points to find the slope. So m is equal to y2 minus y1, or x2 minus x1, which will equal 2 minus 8 over 6 minus -5, equaling -6 over 6 plus 5, -6 over 11 is our slope. And now we want on the line P, and they gave us a point there, so we can plug that into our x and y. So 1 is equal to -6 over 11 times -2 plus b. 1 is equal to 12 over 11 plus b. We're now going to subtract 12/11 from both sides. Get 1 minus 12 over 11 is equal to b. Then we can find a common denominator. And we're going to get -1 over 11 is equal to our b. So y is equal to -611x minus 1 over 11. Okay, question 26. Write the equation of the line in slope-intercept form that passes through the point -7, 3 and is parallel to the line defined by x plus 3y equals 6. So we want something in y equals mx plus b form. First thing we should go for is m, and all we know is that it's parallel to this line, but we don't know the slope of that line quite yet. So we can find the slope of that line by solving for y. Subtract x from both sides, and then we'll divide by 3. Okay, now we know the slope because it's the thing in front of the x of the other line. And now we can use the point -7, 3 to find the line that we're actually concerned, or that we are trying to find. Plus b, so I'll get 3 is equal to positive 7/3 plus b, 3 subtract 7/3 from both sides, find a common denominator, is equal to b. So the equation of the line is our slope, which we found to be negative 3 times x plus 2/3. 27. Write the equation of the line in slope-intercept form that passes through the point negative 8, negative 4, and is perpendicular to the line defined by 6y minus x equals 18. Show all work. So again, we want something that equals mx plus b. The first thing we should go for is the slope. And we know that it's perpendicular to this line, but we don't even necessarily know what the slope of that line is yet. But we can find it by solving for y. So we'll add x to both sides, and then we'll divide by 6. So now we have the equation of the other line, and we have that slope. But since we're looking for the perpendicular slope, it'll be what is called the negative reciprocal, or negative 6/1 is equal to our m, or more simply put, just negative 6 is equal to m. Now that we have that, we can use the point negative 4, negative 8 to find our b value. Negative 4 is equal to negative 6 times negative 8 plus b. Negative 4 is equal to 48 plus b. Subtract 48 on both sides. Negative 52 equals b. So y is equal to negative 6x minus 52. 28. Given the basic function y equals x squared, use transformations to graph f of x is equal to the quantity x minus 2 squared plus 3. List the transformations in the order to be applied. So first we are going to look here, x minus 2, so that means we shift to the right 2 units. And then we see a plus 3 on the outside, so we shift up 3 units. So now we can pick some points to start on the y equals x squared graph and see what these transformations do, and then try and draw a line. So if we start at that 0, 0, we'll shift over 2 units and up 3. And then I'll pick this 1, 1. So we shift to the right 2 units and then up 3. Then this -1, +1. So we'll shift to the left 2 units and then up 3. And that should give us enough to show that in red, that is what is happening to the graph. Question 29. A speeding ticket is $100 plus $5 for every 1 mile per hour over the speed limit. Write a linear function to model the cost S of x in dollars of a speeding ticket for an individual traveling X miles per hour over the speed limit. So the usual linear, we would say y equals mx plus b. In this case, they want to call it S of x is equal to some value times our x plus some constant. So from the problem, if we just get a speeding ticket period, we're going to get, it's going to be $100. And then for every dollar over the speed limit, we're going to pay an additional 5. So that means our slope is 5. So now we have S of x is equal to 5x plus 100. Part B, evaluate S of 15 and interpret the meaning in the context of this problem. So S of 15, anywhere I see an x, I'm going to replace it with that 15. Will equal 75 plus 100 is equal to 175. But now we're going to have to interpret this. So a ticket of someone going 15 miles per hour over the speed limit will cost $175.
Okay, so for number 30, our first step is going to be entering all of this data from this table into our calculator. So we'd go to stat, and then we go to edit, and then we'd enter all this data in, and then after we enter that in, we would go to stat again, calculate, and hit linear regression. And then once we find that, we end up with our A to be 0.51055, and our B to be 104.170. And then it says to round A to 3 decimal places and B to the nearest whole number. So then we get our equation of our line equals 0.511x plus 104. Then we're going to look at our regression line. So we're going to look at that R, and our R is 0.9613, etc. And that's really close to 1, so it's a good fit. It's a strong correlation to our data. And then it's asking us from the model, use the model from part A to approximate the systolic blood pressure for a 55-year-old man. So what we're going to do is take our equation, y equals 0.511. Put in 55 for x plus 104. And then we end up getting, if we put that into our calculator, we get 132. Okay, so this first graph here looks like this. And we know a function that looks like that is going to be our quadratic function, so f of x is equal to x squared. Our second graph looks something like this, and we know this is our cubic function, which is going to be f of x is equal to some x cubed. And then our next graph looks something like this, and we know this is going to be our reciprocal function, which is going to be f of x is equal to 1 over x.